In this example, what we've got to do is work out that we've got a is equal to 2, b is equal to positive 5, and c is equal to minus 1. Alpha plus beta then, again, would be equal to the minus b on a. B is 5, and a is 2, gives us minus 2.5. Alpha times beta would give us the minus c on a, positive c on a. And c is minus 1, so there's our negative 1 over 2. So there's our product and our sum of the roots. So similar to before, alpha times beta, we expand it out. Alpha times minus 1 times beta, and minus 1 times 1. Gives us our product of the roots. We do a factorization of the negative to give us our sum of the roots. We can use our minus a half, which is equal to the product of the roots. We can use minus 2.5 as the sum of the roots, put it into our calculator to give us the answer of positive 3. D, we need to have a look at how we're going to break it down back into our product and sum of roots. So again, we look at our question, we see that we can factorize some terms out. We can factorize this time an alpha squared and beta squared, and we've got the product, and we've got the sum of the roots alpha plus beta. Well, that's our minus 2.5. We can look at alpha beta as alpha squared beta squared as alpha times beta all squared. Alpha times beta is minus a half, square it, and we get positive a quarter, times minus 2.5 will give us 5/8, minus 5/8. This time again, we've got sum of two fractions, which means we have to get a common denominator of alpha times beta. We multiply our denominators by our numerators there to give us alpha plus beta. Product of the roots in the bottom, sum of the roots on the top. We substitute our numbers, we do our division, and we get positive 5. Remember our expansion here that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. If we expand that out and subtract 2 alpha beta, we'll be left with the alpha squared plus beta squared. But now we've got alpha plus beta, and we've got alpha times beta. Sum of the roots, product of the roots. We can put our values back in. We've broken our expression back down into what we know, and then we know the values for these two expressions. And then we can do our calculation to come down to 7.25. This time again, we've got alpha over beta and beta over alpha. Our common denominator would give us alpha beta. Our multiplication gives us alpha squared, and multiplication there gives us the beta squared. So, but we know from our previous part that alpha squared plus beta squared gave us 7.25, divided by our product of the roots, which is minus a half, and we come down to minus 14.5. H relies on us to do a little bit of work. This is one of the harder ones. We want to find alpha minus beta. Firstly though, it says find alpha minus beta all squared. That's a bit of a hint. Now we want to get that alpha minus beta all squared is equal to that expression. Well, how do we do that? Well, we know that alpha minus beta all squared would be equal to alpha squared plus beta squared minus 2 alpha beta. That's just expanding it, our perfect square there. But we know that alpha squared plus beta squared would be alpha plus beta all squared minus 2 alpha beta. Then we've got this minus 2 alpha beta extra. We collect our like terms and we get minus 4 alpha beta. So with our alpha plus beta all squared minus 4 alpha beta, that's what would be equal to alpha minus beta all squared. So again, we've broken it down to the sum of the roots, the products of the roots. We can do our substitution. A little bit extra this time because we've got alpha minus beta all squared is equal to 8.25, which means we just have to take alpha minus beta equal to the square root of 8.25, which we can put down as a third as root 33 over 2. Remember, you've got to keep getting back to alpha plus beta and alpha times beta, because that's what really we've got the values for. If we can't get the values for that, then we won't be able to solve these roots of a quadratic.